Let's do this integration by substitution. They've told us to use that. So first thing that we need to do is we need to get rid of all of our u's all of our x's in the integral and replace them with u's, and we also need to replace the dx with a du. So first things first, let's figure out what this is, because that often means that some of this simplifies. We could just use what they've given us straight away, which gives us du dx is equal to half x to the minus half, and we could substitute this in. However, I don't like this substitution. There's a lot to go wrong with it. We'll do it anyway, but we'll discuss a slightly nicer method later on. Okay, so now we need to figure out what is dx equal to. So I'm just going to rewrite this in that form, just nicer to work with. Indices are nice for differentiating, surds are nice for rearranging. So that tells me that 2 root x du is equal to dx. So we can replace our dx with that. And that cancels. And we're left with replacing our x with u squared. Okay, once we get to this stage, it's not a standard integral. However, this denominator factorises, so we'll do that. It's difference of 2 squares. And now we can integrate by partial fractions. So we'll just do quick partial fractions over here. So I'm sure you're familiar with partial fractions. You're going to get 4 over your denominator. So we get that. Multiply through by this denominator. We've got that. Setting u equal to 2 gives us 0. B is 1. U equals minus 2 gives us a is minus 1. And so we know that this integral over here can be written as okay, we've got that. Now we can integrate each of these terms and simplify. So we'll just move over to here now. Integrate the first term. Minus. And then plus. Don't forget your plus c. And then that's a negative log, so it could be rewritten as denominator inside 1 logarithm. And then we just need to replace our x's again. Okay, just a few little notes. If I were doing this myself, I probably would have squared both sides of this to get u squared is equal to x. Only reason is when I then differentiate it, I get 2u is equal to dx du, meaning that my dx is equal to 2u du, and it's just nicer to work with than that, but it's exactly the same thing. And another thing that we could have done at the very end here, rather than plussing the c, I could have plussed ln k or something like that. The only advantage of doing that would be, at the end here, I could have multiplied through by ln k. I could just put that inside my logarithm too. Okay, just little things you might want to consider. That's how to do that question.